In this video, we are going to find the derivatives of these 6 inverse trig functions, as well as solve some examples for the trig functions. So let us get started. So we are going to start with y is equal to sine inverse of f of x. So what you have to do is to take the sine of both sides. So I have sine y will just be sine of x sine f of x. So this will give me sine y is just sine of x sine is just f of x. So y is a function of x. So I can find the derivative of both sides with respect to x. So it will be dx of sine y, and then I will have dx of f of x. So from this part, I can apply chain rule, that is in the left hand side. So it will just be dy of sine y, then dy dx, because y is a function of x. Then I will just have f prime of x, which is the first derivative of f of x. So if I differentiate sine y with respect to y, I will just have cos y is dy dx, then I will have f of x. So I can divide both sides with respect to cos y. So I will just have dy ds will just be f prime of x over cos y. So from my trig identity, I know that cos square y plus sin square y is just 1. So it means cos square y is just 1 minus sin square y. So it means I can take the square root of both sides, and cos y will just be square root of 1 minus sin square y. But from here, you can see sin y is equal to f of x. So I can make that substitution here. So I will just have cos y is just 1 minus f of x squared. So I can substitute this into this formula. So it means my dy dx is just f prime of x all over square root of 1 minus f of x squared. So I can substitute it here. It means y is equal to sine inverse of f of x, if differentiated, will just be f prime of x over square root of 1 minus f of x squared. So now let us go through these examples. So it means if I have y is sine inverse of x, it means my f of x is just x. So if I differentiate it, I will have 1. So I can just substitute this into this formula. So it means my dy ds will just be 1 over root of 1 minus, and my f of x is just x squared. So if I have y is equal to sine inverse of s cube, so it means my f of s is s cube, and my f prime of x is just 3x squared. So if I substitute it into the formula, it means my dy ds is just 3s squared divided by root of 1 minus s to power 3 squared, which is just s to power 6. So now let us move to the second function. So y is equal to cos inverse of f of x. So if I take the cos of both sides, I will have cos y is just cos of cos inverse of f of x, so it will just be cos y is just f of x. So I can differentiate both sides with respect to s, so it will be d dx of cos y, and then I will have f prime of x if I differentiate it with respect to x. So I can apply chain rule, so it will be d dy of cos y times dy dx, because y is a function of x. Then I have f prime of x. So if I differentiate cos y with respect to y, I will have minus sin y dy ds is just f prime of x. So it means my dy ds, if I divide both sides by minus sin y, so I will have minus f prime of x over sin y. So from my trig formulas, I know that I have sin square y plus cos square y is equal to 1. So if I make sin y the subject of the formula, it will just be sin y is root of 1 minus cos square y. But cos y is equal to f of x, so I can make the substitution here. So it means my sin y is just root of 1 minus f of x squared. So if I substitute it into this formula, it means my dy dx here will just be minus f prime of x over root of 1 minus f of x squared. So let us go through this example. So I have y is equal to cos inverse of sin x. So it means my f of x is just sin x. So my f prime of x, that is if I differentiate it with respect to s, will just be cos x. So I just need to substitute it in this formula. So it means my dy dx, I have minus f prime of x, which is cos x, divided by root of 1 minus, and my f of x is sin x, so sin square x. So that will be my solution. So let us move to the third function. So I have y is equal to tan inverse of f of x. So if I take the tan of both sides, I will have tan y is just f of x. So I can differentiate both sides with respect to x. So I will have d dx of tan y is just f prime of x. So applying chain rule to the left hand side, I will have d dy of tan y dy dx. So if I differentiate tan y with respect to y, I will have sec square y dy dx is just f prime of x. So my dy dx is just f prime of x all over sec square y. From my trig formulas, I know that 1 plus tan square y is just sec square y. But my tan y is just f of x. So if I make the substitution here, it means my sec square y will just be 1 plus f of x squared. So if I substitute this into this equation, it means my dy dx will just be f prime of x divided by 1 plus f of x squared. So now let us go through an example. Y is equal to tan inverse of s over 2. So it means my f of x is s over 2, and my f prime of x will just be 1 over 2. So if I make the substitution into the formula, it means my dy dx will just be 1 over 2 divided by 1 plus s over 2 squared. So if I solve further, my dy dx will just be 2 over 4 plus x squared. So moving to the next trig function, I have y is sec inverse of f of x. So if I take the sec of both sides, I'll just have sec y is just f of x. So if I differentiate both sides with respect to x, sec of y f prime of x. So I can apply chain rule to the left hand side. So it will just be d dy of sec y dy dx f prime of x. So if I differentiate sec y with respect to y, I will just have sec y tan y dy dx is f prime of x. So it means my dy dx is just f prime of x divided by sec y tan y. So I know that 1 plus tan square y is just sec square y. So my tan y, if I make it the subject of formula, it will just be tan y is equal to square root of sec square y minus 1. But my sec y is f of x, so it means my tan y is square root of f of x squared minus 1. And also my sec y is equal to f of x. So if I make the substitution into this relationship, I will end up with derivative will just be f prime of x divided by, I have sec y, which is f of x, then tan y is square root of f of x minus 1. So it will be square root of f of x squared minus 1. So if I have y is equal to sec inverse of 2x, it means my f of x is 2x and my f prime of x will just be 2. So substituting these 2 into the formula, my dy dx will just be 2 all over 2x, then square root of 2x squared will just be 4s squared minus 1. So this is my derivative for sec inverse of 2x. So moving to y is cot inverse of f of x. So if I take the cot of both sides, I will have cot y is equal to f of s. If I differentiate both sides with respect to x, cot y f prime of x. So if I apply chain rule, I will have dy of cot y dy dx. So if I differentiate cot y, I will just have minus cosec square y dy dx is equal to f prime of x. So if I divide both sides by minus cosec square y, I will have my dy dx to be equal to minus f prime of x divided by cosec square y. So I know that 1 plus cot square y is just cosec square y, but my cot y is just f of x. So it means my cosec square y is just 1 plus f of x squared. So I can make the substitution into this in order to get my dy ds. So my dy ds for cot inverse of f of x will just be minus f prime of x all over 1 plus f of x squared, which is the negative for the tan inverse of f of x if you compare the two. So let us go through an example. So y is equal to cot inverse of s minus 3. So it means my f of x is s minus 3. My f prime of x will just be 1. So my dy dx will just be minus 1 all over 1 plus s minus 3 squared. So this is my solution. For the last function, I have y is cosec inverse of f of x. So if I take the cosec of both sides, I will have cosec y is just f of x. So if I take the derivative of both sides with respect to s, I will have dx of cosec y is just f prime of x. So if I apply chain rule to the left hand side, I will have dy of cosec y dy dx f prime of x. So if I differentiate cosec y, I will just have minus cosec y cot y dy dx f prime of x. So it means my dy dx just minus f prime of x all over cosec y cot y. But 1 plus cot square y is just cosec square y. So if I make cot y the subject of the formula, I will have cot y will just be cosec square y minus 1. But my cosec y is f of x. So it means my cot y will just be f of x squared minus 1. So if I make the substitution here, I will just have my derivative will just be minus f prime of x all over my cosec y is already f of x, so I will have f of x, and my cot y is this part, so it will just be square root of f of x squared minus 1. So let us see an example. Y is just cosec inverse of 1 over x. So it means my f of x is 1 over x. So my f prime of x will just be ln x. So dy dx will just be minus ln x divided by 1 over x square root of 1 over s squared minus 1. So if you want to learn how to solve simultaneous equations using Cramer's rule, watch the video on the screen. Please like and subscribe to the channel. Thank you for watching.